Right. Well, I hope everybody had a good 3-day weekend. Got a short week. If you don't include this week, we have 3 weeks until the end of the 9 weeks in spring break. If you do include it, then we got just under 4 weeks. That's how you look at it. A couple things that are going to be happening. So our AP exam is on Tuesday, May 13th. Now, before that, there are 4 meeting times when we're going to have what's known as AP prep sessions. There's going to be 2 on a Saturday morning, 2 on Monday afternoons, and we've got the first one actually coming up this Saturday, the 22nd, from 9 a.m. to noon over at Coronado High School. So these are not mandatory, but if you feel the need to go ahead and start, preparing, reviewing material, getting ready for that test, I would definitely encourage you to go ahead and show up to one of these. You don't have to show up for the entire thing, or if you show up late, or if you have to leave early, perfectly fine. This first one is going to be a review of polynomials and rational functions, which we actually just went over quite recently. So if you're not able to make it to the first one, perfectly fine. We got Ms. Hanson's going to be the first presenter from 9 to 10:30, and then I'll take over from 10:30 to noon. We'll talk about rational functions. But if anybody is interested, we have that available to you. So tomorrow, I'm going to go ahead and think about it. Check your calendars. Tomorrow, I'm going to ask again if anybody is planning on going. I need to kind of get a rough head count so I could let Ms. Hanson and a few other folks know how many to expect. So, any questions about the AP prep session? Okay, let's see. Tomorrow we got ourselves a quiz over 1.12. That would be the transformations of functions. We talked about that on Friday, so if you have any questions, come on in. Tomorrow during third period we have a hazmat drill. Okay, so just be thinking about that ahead of time. That should be pretty easy. And then here's the big one. Next Thursday, the 27th. We have our second exam because we are getting close to the end of the 9 weeks. So this is going to cover lessons 1.11 to 2.1. So the sequences that we are talking about today, at least one problem from that material will show up on the exam. And we'll do like we always do, on Friday this week, I'll give you a 3x5 note card, whatever you want to put on there, maybe the binomial theorem. That will make an appearance on the test. Pascal's triangle, the sequences, rational functions. Anything you want to put on there and make your life a little easier, definitely go ahead and do. But are there any questions? Okay, well, what do you say we go ahead and get started? So I do want to take a look at just one problem from 113.14, where we're finding the model equation from a data set. Just to make sure we remember the keystrokes, all that good stuff. So let's look at number 2. Did anybody need a copy of this? Okay, a few folks. Okay, I got a few left. Would you pass it back, please? Anybody else? All right. Well, let's see. It says the price of Amazon stock fluctuates over time. On December 6, 2019, one share of Amazon stock was $87.58. The table above gives the price of one share of Amazon stock in dollars for selected times T, the number of months after December 6, 2019. So based on the data presented in the table, would a linear, quadratic, or cubic function be most appropriate? Give a reason. Okay, what do we think? Addie, what do you think? Linear, quadratic, or cubic? Looking at our table here. So do we notice any kind of pattern in the table that could help us decide? Okay, no? Okay. Well, let's look at the top row. What do we notice about the time in months? Is it constantly increasing? Yeah, it's constantly increasing. Okay, so that's good. Now let's look at the amount in dollars. Is it constantly increasing? It doesn't. It increases to a point. Let me go ahead and highlight this. And then it starts to decrease. But if you go ahead and compare the values, like let's say starting from the outside and working your way, 87.58 and 90.98, they're pretty close to each other. Remember, we used that word roughly last week because we're not looking for exact values, but we're just looking for the best fit. So as I work my way in, it's almost like we see what in that second row? What's the word I'm fishing for? Starts with an S. Symmetry. There we go. So what are we thinking here? Quadratic. Quadratic is going to be the way to go. So quadratic. Okay. So now, having chosen quadratic, find an appropriate regression function to model the data. Okay, so this is where we're going to put it in the calculator. Okay, so we want to remember the keystrokes, okay, because we do have a test coming up next week, possibly could have a problem like this. All right, so I'm going to go to new document. If there is already one in your calculator, just click no, we're not going to save it. Remember, we want lists and spreadsheet. Okay. Now, I know the table is using T and A of T. I'm just going to go back to good old X and Y. Okay. All right. So, Audrey, what are we doing with this equals row? Nothing. We're not going to touch it. Okay. So this first column is my first row here. So 0, 1, 13.5, 19, 26.5, 31.5, and actually put in a value there I shouldn't have. 31.5 and 35. Excuse me. All right, then I'm going to hit Control 7, get me back up to the top, where I have 87, 58, 124, 15, 164, 61, and I'm not typing well today. Okay, 185, 97, 152, 60, 122, 42, and 90, 98. Okay, so I got my data in. So I'm going to go back to my home screen. Okay. Ayla, what do I choose? Which of these at the bottom do I choose? I know which one you're talking about. It looks kind of purplish to me. Okay, data and statistics. Looks like a bar graph. Okay, so I'm going to choose this. Remember, this is the only time our screens are going to look different. You can definitely use the touchpad to move the arrow. I personally prefer the tab button because that brings up the titles, the headings that we typed in. You always want to do the horizontal X first. Now, the reason at the very beginning that it shows one of the dots above the other is it's just not going to overlap. They're so close together that it just kind of put one above the other. Now, if I go ahead and click tab and do the Y, and we see we have somewhat of a parabolic model here. Okay. Looks almost quadratic. It's not going to be perfect, but that looks to be our best model. So once we've got my scatter plot, I'm going to push menu. Akil, where do I go? We're going to choose analyze, regression, and we decided it was quadratic. So here's my model. There's my prediction equation. Okay. So I'm going to go ahead, round these values to the nearest thousandth, which is 3 decimal places. Okay, so when I come back over here, this is what we got, so I don't have to write it again. Negative 0.269t squared plus 9.162t plus 99.972. Okay. Now, I've had this question throughout the day. What if you went back like I did in the calculator? You just went and said x squared and x. Perfectly fine. Doesn't change anything. Okay. All right, so I've got my model. Now, in part C, okay, using that model, what's the predicted price of 1 share of Amazon stock when t equals 16 months? So April 6th of 2021, 16 months after that December 6th. Okay, well, all I'm going to do is go ahead and plug in that 16. I'm not going to remember that number, so come on back over here. So I know it's a negative point. It was 269, 16 squared. Then we're going to add 9.162 times 16 plus 99 point, it was 972. Okay. All right. So what am I going to get when I push enter? 100 and something to 1. William, what'd you get? There we go. 177.70. Okay. $177.70. And then finally, part D, the actual price for one share of Amazon stock on April the 6th, 2021 was $168.61. What's the residual value? Okay, so Vera, how do I find the residual value? We subtract. Okay, so Bailey, is it the actual minus the predicted or predicted minus actual? The actual value minus predicted. So I'm going to start with this 168.61. Come on back over here to my calculator, $168.61 minus, and you can type it in, but I'm going to use my touchpad here. So it looks like my residual is a negative 9.09. Okay. There we go. Now, based on what we see here, would you say that our model over or underestimated the actual values? It overestimated. Okay, if you get a negative residual, that's an overestimation. Positive means an under. There you go. That's basically what that section was over. Okay. Questions? All right, well, let's take a look. Let's get rid of this. And let me go ahead and set this up for the next class. Okay, let's go ahead and pull out the notes to 2.1. Did anybody need a copy of this? Anybody else? Just 1.12 transformations. In fact, this material will show up on the test next week, but I believe I have a quiz over it early in the week for practice as well. Okay. All right, so we actually should be getting 2 grades next week. Yeah. 7, I want to say off the top of my head. You know, there's a couple of College Board. There's a few open-ended, so it's a mixture. Okay, well, let's talk about some sequences. A sequence is an ordered list of numbers or other mathematical objects that follow a particular pattern. Okay, so a sequence is a function from the whole numbers to the real numbers. Now, remember, we're talking about the term number and then the value of that term. Okay, for the term numbers, we can only plug in whole numbers. You can have a 0th term, 1st term, 2nd term. There's no such thing as the 1.7th term. Okay, you can't have a portion of a term. But the value of the term itself can be anything, hence why we have the real. Okay, so what we saw last week was that when we're talking about arithmetic sequences, they're going to act just like linear functions, except they're not consistent. So in every way, they're linear functions. But if I look at a visual, if I plot these points, I'm not going to connect them. Okay, again, because you can only plug in whole numbers. We have what's called a common difference D. This is what you're going to be adding or subtracting over and over again to create the sequence. And here's our formula. A sub n equals a sub k plus d times n minus k. This is what we're going to be using a lot today. All right, where a naught is the initial value. That's another version of the formula up here. D is the common difference, and a sub k is the kth term. Okay. Well, we are currently on example 3. So it says, let a sub n be an arithmetic sequence, and then it says a sub 3 equals 8. So what is this notation actually telling me? 8 is the what? The 3rd term. That little subscript tells me the term number we're dealing with. So the 3rd term is 8. It gives me the common difference D is -3. Now, when it says find an expression for a sub n, you're going to plug into the formula, but not in. That's the one variable you're going to leave alone. Okay. And then when we finally get that formula, we're going to use it to find the 12th term. Okay, so a sub n is equal to a sub k plus d times n minus k. So here's the formula we're going to work with. Now, because on this one, I'm not going to be plugging in anything for n, that means that this 3 right here, what do you think it represents? What's the only other variable we got? K. got to be k. So this would be our kth term. Now, for the first couple of examples, I'm going to go ahead and do this because I really want you to make a connection with something. And then it won't be long. I'm just going to go ahead and plug in directly. So the nth term, a sub n, equals, we have the third term, d is minus 3, times n minus, now here's the thing I want to go ahead and point out. Okay, because I'm about to plug in the third term, that means k equals 3. So n minus k would be n minus 3. When you're using the formula, you're not only plugging in the value of the term, but the term number itself. Okay, I just want you to make sure to see that that's going to be happening. But now we know what the third term is. So a sub 3, I'm going to replace it with 8. Let's go ahead and distribute. That's a minus 3n plus 9. So this is a negative 3n plus what? 17. And remember I said these were linear functions. So we've got the slope-intercept form, mx plus b right there. That's my expression. That's my formula. That would find me any term in the sequence that I want. Okay. Now this one wanted the 12th. Okay, so because I'm looking for the 12th term, that's what n equals, 12. So negative 3n is negative 3 times 12 plus 17. Well, negative 36 plus 17, what am I looking at? Negative, was it 19? And that's it. That's all there is to it. Question. Okay, well, let's try number 4. Let a sub n be an arithmetic sequence with the second term equal to 7, the sixth term equal to 9. Find an expression for a sub n, and then use the expression to find the 24th term. Okay. Now, what's different about this problem? What is it not giving me that number 3 did? It gave me the common difference. See, think back to algebra. If you had two ordered pairs and you wanted to write the equation of a line through those 2 points, the first thing you would find is your slope. Well, that's what our common difference is. So once we find that, we can choose which ordered pair to write the equation with. So once we're done, I can use either of those terms and it will give me the exact formula that I'm looking for. Okay, but first we got to figure out what d is going to look like. So here's my formula. A sub n equals a sub k plus d times n minus k. Now, so everybody's on the same page and there's no confusion. We're going to work these problems like this. Use the larger term number for n. Okay. Whatever the larger term number is, that's going to be your n. Because when you're looking at the formula, I mean, think about it. You find the nth term by using the kth term. So you have to use a smaller term number to do that. So because we have the second and the sixth term, we're going to say that n is 6. That means that k is going to be 2. We're just always going to work in that way. Okay. So let's plug in. So this is the last time I think I'm going to use the notation. But we have that the sixth term is going to equal the second term plus the common difference d. What do you think n minus k is going to look like? 6 plus 2. Okay, I'm just wanting to really emphasize the point. Okay, we're finding the nth term by using the kth term. So I would find the sixth term by using the second term. It's always a previous term that's going to help you here. So let's plug in. The sixth term is 9. The second term was 7. We have no idea what d is, but 6 minus 2 would give me 4. And see, now we got ourselves just a simple 2-step equation. Okay, so if I subtract that 7, 2 is equal to 4d. So that means that d equals 1/2. There we go. So now this problem is just like the previous one. I've got d, but I've got my choice of terms that I could use. Does not matter which one we choose. Now, just so everything's consistent, okay, because we have to plug in the kth term, let's just use this second term right here because k is already 2. We'll just go ahead and keep it the same. Okay. So a sub n equals, at this point I'm just going to plug in. So it's 7 plus 1/2 times n minus, what am I going to subtract from n? Remember, what term number is 7? 2, it's the second. So see, I'm not only plugging in the value of the term, but I'm also plugging in the term number that I'm using. Okay, both are just as important. Okay. And now we do just a little bit of algebra. So a sub n equals 7 plus 1/2 n, and then half of -2, that's a -1. So it looks like I'm going to get 1/2 n plus 6. Again, I got a slope-intercept formula. Okay, there's my line. Is everybody okay? Anybody confused? Good old days of algebra coming back to you? Maybe, maybe not. Okay. Now, the problem isn't done. It wants me to what? We still got to find the 24th term. Okay, so let's do that. So a sub 24 is equal to 1/2 n is 1/2 of 24 plus 6. So what is that? 18. 18 is the 24th term. Okay. Easy, easy, easy. You're probably thinking, so easy, I'm ready to do one on my own. Okay. Now, I'm going to go ahead and help you set this up, and then I'm going to give you about a minute or so to try this on your own. So they're giving me arithmetic sequence shown above. Find an expression for a sub n, and then use that to find the 17th term. Okay, so according to this discrete grid here, what's the 0th term? 8. And the first term is 6. Looks like that's a 2 right there. The second term is 4. The third term is 2. So this is my sequence right here. 8, 6, 4, 2. What's the common difference? 2? Close. -2. The common difference can be negative because you can add the opposite. I mean, that's exactly what subtraction is. So in this case, D equals -2. So now what I want you to do is exactly what we did just a moment ago. Use any of these points, these terms. It does not matter. Go ahead and find me the linear function, and then find me the 17th term. And then we'll go back and I'll prove something to you. Then after this, we'll get into geometric. So should be on track tomorrow after the quiz to wrap up this lesson. In fact, the homework that you picked up, okay, on the way in, this will be due on Friday. So we'll talk about some examples on Friday. Is everybody ready, or we need a little more time? Okay, here's what you should be getting for the nth term, -2n plus 8. That look familiar? Okay. With the 17th term, can anybody tell me? -26. Now, I want to show you that if you're dealing with an arithmetic sequence, it makes absolutely no difference what term you use. Choose one of these four terms right here. So you want to use the first term. Okay. So I'm going to go ahead and plug in. So a sub n equals, well, the term value is 6, okay, minus 2 times n minus, now remember 6 is the first term. So it's got to be n minus 1. Well, when I go ahead and distribute, that'd be 6 minus 2n plus 2 gives me my linear function. Now choose another. Choose another, because I want to show you it doesn't matter. Okay, let's use the second term. Okay, so a sub n equals, well, the second term is 4. That would be minus 2 times n minus, what am I going to subtract here? 2, because 4 is the second term. Okay, so if I go ahead, 4 minus 2n, negative 2 and negative 2 give me plus 4, so I still get the exact same thing. That will work out every time if it's arithmetic. How are we doing? How many people got that right? Nice. Okay. Well, let's take a look at geometric. Okay. So geometric, we got a couple of properties here. Geometric has a common ratio, not a common difference. So the common ratio is R. Ready? Okay, it's R. Okay. So you're not adding or subtracting the same number over and over again. You're either multiplying or dividing by the same number over and over again to create a geometric sequence. Okay, you're going to find they work just like exponential functions, except they're not continuous. So everything you know about exponentials, it's going to work here. It's just that when we look at a graph, we can't connect them. Now, we got a couple of formulas. Now, the first one is super easy to remember if you're a Star Trek fan. See, it says G naught R to the N, Gorn. How many people in here are Star Trek fans? There are not a lot of Star Trek fans here at Lower Chi. That's kind of hurting my heart. But a Gorn is a humanoid lizard species. No? I'll show you at the end. It'll be nice. It'll be nice. So while you have that formula right there, we're not going to be using it a whole lot. We're going to be using this one right here. Okay, so G sub n equals G sub k times R to the n minus k. The nice thing about a geometric sequence, once you substitute in, there's no simplifying. You got your formula. Okay, everything you need. All right, there's the listings of all the terms right there. Let's just look at an example. Okay, so I've got 8 times 1/2 to the n. Anybody tell me what's the common ratio in that function? 1/2. It's the base holding the power. So R equals 1/2. Well, let's start plugging in some numbers here. So 8 times 1/2 to the 0. Well, what's anything to the 0 power? What was that? Read, what was that? 1. 8 times 1 would give me 8. So 8 times 1/2 to the first. So half of 8 would be 4. And see, at this point, we can already see the pattern. We don't have to continually substitute. We're just taking half of the previous one. So half of 4, that's a 2. Half of 2, and it just keeps going. All right, so let's see here. The 0th term is 8. Okay, the first term is 4. Okay, second term is 2. Third term is 1. And you might remember from algebra, since your base is between 0 and 1, that's a decay. So it makes sense that it's sloping down to the right. But why would I not connect them? That's right. It's a sequence. It's not continuous. Okay, we can only have whole number terms that we're going to plug in. Okay. Well, let's move on to example 6. For each of the following, determine if the sequence could be geometric. So we're going to say yes or no. And then if yes, identify the common ratio. Remember, that's R. Okay. Well, the first one, it's giving me a function, 3n squared. Let's not even worry about the table. Okay. Is that an exponential? Ryan, what do you think? 3n squared, is that an exponential? Okay, no. What is it? It's quadratic. Okay, so this is not geometric, so there's not going to be any common ratio. In fact, one of the things you should be able to see, your y values should be proportional if it's exponential. We're going to talk about this more in the next lesson, but I got 0, 3, 12, 27. There's no one value that I can multiply or divide each of those by to get that pattern going. But now, what do you think about B? 4 times 2 to the n minus 1. What do you think, yes or no? That's definitely a yes. In fact, we know it's exponential because your variable is in the exponent. Okay. In fact, what's R? R is 2. Remember, it's the base. And if I look at the table here, now, of course, you have to have consecutive equal length input intervals. But 2, 4, 8, 6, we're constantly multiplying by 2. Now, what if they don't give me the function like in C? 1, 3, 2, 6, 4, 12, 8, 24, and then it continues. So let me ask you a question. Last week, when we had a sequence and we thought it was arithmetic, what did I do with consecutive terms to test that? We subtracted them. So if you think that a sequence could be geometric, you're not going to subtract consecutive terms, you're going to divide. But you're always going to divide by the previous one. So let's say the first set, will 3 divided by 1 be the same as the next set? 2 divided by 3. Will that in turn be the same as the next set? And then over and over and over. So what do you think, looking at what we got here? Yes or no? Okay. Andre, what do you think? Yes or no? Do all of these match up? No, but 3 over 1 is 6 over 2, right? It's got to be every single one of them. Since they all don't match, that is not geometric. We don't know what it is, but it's not geometric. Okay. Well, let's try 16. So we're going to divide consecutive terms. So negative 8 sixteenths, does that equal 4 divided by negative 8? Does that equal negative 2 over 4? And so on down the line. Would all those be the same? Yes. So this one is geometric. In fact, what is R? Negative 1/2. It's the simplified version of every one of those ratios. R equals a negative 1/2. Okay. Not too bad, right? Okay. All right, we've only got a couple of examples left and we are done. Example 7. Let G sub n be a geometric sequence with G sub 1 equals 12 and the common ratio equals 2. Find an expression for G sub n and then find the fourth term. Okay, so here's my formula. G sub n equals G sub k times R to the n minus k. Excuse me. So let's see here. G sub n would equal, well, the only term I have is the first, it's 12. So I'm going to say 12 times the common ratio 2. But what's my power going to be? N minus what? Okay, now what do you think? N minus what? No, see, 12 is the value. Up here, it tells me the something number. It's not 12. It would be 1. Because 12 is the first term. So you're plugging, it's just like the arithmetic, you're plugging in the value of the term and the term number. And see, there's nothing to simplify here. There's your function. Now, if I want to go ahead and find the fourth term, so G sub 4 equals 12 times. Well, if I plug 4 in there, this would be 2 cubed. Well, what's a 12 times 8? And do what? 6. Okay. So now we got one problem left and we are done. Any questions so far? How are we doing? Okay. Well, we got ourselves another graph here. It's geometric. Okay. So I'm going to go ahead and get you started. What I'm going to want you to do, find the expression for g sub n, and then find me the 10th term. I will give you a heads up. The 10th term is going to be a fractional value. Okay. So let's see here. The 0th term is 8. The first term is 4. The second term is 2. Looks like the third term is 1, and it'll keep going. Now, one thing I want to point out here, and I'm going to show you. You remember how we had this same type of problem with arithmetic? Let me come back over here. Remember how it did not matter what term number we chose? It always simplified to the same formula? That does not happen with geometric. You're still free to use whatever term number you want, okay? But your formulas are going to look different. They're still going to give you the same answer, though. Okay? So you choose which one you want to use, find R, find me everything we need. Okay. So let me give you about a minute or so on that. And then we are done. Okay, what do we find for R? How do I go from an 8 to a 4 to a 2 to a 1? 1/2. So we're constantly multiplying by 1/2 each time. Do we need a little more time, or are we ready? We need a little more time. Okay, so here's what you should be getting for the 10th term, and it doesn't matter which term number you use, they're all going to be the same. You should have ended up with 1/128. Now you're already smiling. Did you get that right? Oh, you're just thinking how much fun you have in math? Or... Oh, okay. How many people got that right? Oh, okay, let's talk about it. Okay, so we got the value, the common ratio is 1/2, right? Okay, so choose one. What term would you like? Let's use the 0th term. Okay, remember, this is your general form. G sub n is equal to G sub k times R to the n minus k. So let's say I go ahead and use this one. So I'm going to go ahead and say G sub n is equal to, well, the term value is 8 times 1/2. What would my power be? What's n minus k? Remember, 8 is what term number? 0. So n minus 0, well, that's just n. Okay. But let's say we decided to go ahead and use a completely different term, like maybe we use the 3rd term. Okay, so I could easily have said G sub n is equal to, well, the term value is 1 times 1/2, but this time it would be n minus what? N minus 3, because 1 is the 3rd term. Either one of these is going to give you what we're looking for. Okay, so we're going to go ahead and plug in 10. So I'll just show you quickly on the calculator. 8 times 1/2 to the 10th. So 8 times 0.5 to the power of 10. Okay. Now let's go ahead and change that. Number, approximate fraction, 1/128. Now, of course, you could have done that by hand, but I'm just going to go ahead and make this quick. Okay. Now, the other one was 1 time, so I'm not going to worry about that. So it was 0.5. If I plug in 10, remember this one we had n minus 3. It'll pop up. So 10 minus 3, I'm just going to raise it to the 7th power. See, it gives me the exact same decimal, so it's going to give me the exact same fraction. Okay. So different formulas, but same answer. Okay. Is there anything I can do to help? Because only a few people raise their hands. Okay, then we are done. Let me go ahead and set up for the next class. Okay. All right, go ahead and shut this.